Okay, hello bachcho. Myself Mrs. Neha Magdum, and today I'm going to explain one of the mechanics topic, which is projectile motion. Might be you have heard about different motions like circular motion हो या rotational motion हो या projectile motion हो. तो उसमें से जो बेसिक मोशन है वो हम प्रोजेक्टाइल मोशन आज के लेक्चर में कंप्लीट करने वाले हैं. उसमें we will try to find out equation of projectile motion, and we will discuss what must be the time period for trajectory of projectile motion. So without wasting time, let's begin with the projectile motion. So this point is involved in projectile motion. This point is involved in your third topic, state board third topic, in motion in a plane. ठीक है. तो why this motion? We will start with the planar motion. Okay. So why this motion is considered to be planar motion? Do you understand that? See, this is the plane. Plane means if I'm taking this as the origin, so this must be the x-axis and this must be the y-axis. Okay. So whenever there are two coordinate systems are involved in specific motion, so that motion is considered to be a planar motion. So we are taking study of projectile motion in planar motion. So there must be two coordinates which are important for explanation of this motion. So how that two coordinates are important? See, projectile, yeah, projection means what? Whenever the object is thrown like this. See, I'm taking a pen in my hand and I have thrown this pen in specific direction with respect to angle to the horizon. So this pen will come here. So can you imagine the trajectory? See, this is the trajectory of the pen. Are you understanding this? This is the trajectory of pen. So here the pen is traveling along x-axis and also it traveling along y-axis also. Means the pen or the object is performing some displacement with respect to time along y-axis also and along z-axis. Finally the object is coming here. See, there are different cases for the projectile motion. Not necessary horizon to horizon fall should be there. Like if I'm throwing some object and the object is traveling along the projectile motion and is coming to this specific level, तो इसको बोलते हैं same level or horizon to horizon projectile motion. But not necessary this is the only projectile motion. ये aircraft का example है. I'm ignoring the resistances or whatever the obstacles or other factors that aircraft is experiencing. I'm not taking that path, but I'm just taking the trajectory of the aircraft. Somewhere the aircraft is taking off और वो एयरक्राफ्ट क्या हो रहा है, यहाँ से निकल रहा है, समझ लो इट इंक्लाइंड बाय एन हॉरिजॉन सम एंगल ऑफ इंक्लिनेशन थीटा एंड इट रीचेस टू सम हाइट एंड इज कमिंग डाउन एंड इज लैंडिंग ऑफ. ठीक है. तो ट्रैजेक्टरी ऑफ aircraft is, we can say, this is the projectile motion. Or if anyone or any person is having some object in his hand and he is throwing that object from top of the building, so that projectile motion will be something like this. So this must be the projectile motion. We're gonna discuss this motion in free fall का case. Free fall के case में हम अलग अलग उसके cases हम पढ़ेंगे. But this is also a projectile motion. Here the throw point and the catch point, or we can say the throw point and the land point are different. समझ गए? So here there must be a reverse case also. Somebody is throwing object to the top of the building और terrace पे कोई कुछ फेंक रहा है, तो here is your top position, here is your throw position. तो this is another point or another case. यहाँ पे क्या था, projectile का trajectory will be like this. यहाँ पे क्या था, projectile का trajectory will be like this. In both the cases it is okay. This is also a projectile motion. But as whenever we concern about our syllabus, for projectile motion we have to horizon motion. Means we are going to discuss some factors related to projectile motion to horizon. So I will draw first projectile motion का diagram here. See, I'm throwing this object like this and is coming down here. ठीक है. समझो किसी बंदे ने एक बॉल को किक करा, तो बॉल इज लिफ्टेड और बॉल इज इंक्लाइंड बाय एन इंक्लिनेशन. वो जो कुछ थ्रो होगा ना बॉल का, आई एम शोइंग ऑन टू दिस एक्सिस. So this must be the throw or exactly the throw or projection of the ball with respect to horizon. तो ये horizon को कुछ ऐसे incline होगा, ठीक है, and this angle is said to be angle of projection. समझ लो projectile motion क्या है. projectile motion basically a projectile motion is a motion under the action of gravity. अलग अलग बुक में अलग अलग, this is a planar motion, this is motion under the action of gravity, but I think this is the planar motion, motion under the action of gravity. क्योंकि जो चीज ऊपर जा रही है वो नीचे आ रही है, किसके प्रेजेंस से वो नीचे आ रही है? ड्यू टू action of gravity. So this is the pure motion under the action of gravity. We consider this motion should be a free fall because there is no obstacle or no any we can say resistance which is coming in the path of projectile. So यहाँ पे जो projection हो रहा है, we are taking that angle of projection, means angle made by the throw point of the projectile with respect to x-axis or the horizon. We consider that angle is angle of projection. ठीक है. So here is your projectile is thrown up with some velocity u bar. See, ये एक प्योर मोशन है, तो मोशन में हम सब काइनेमेटिकल इक्वेशंस यूज करेंगे. तो मोशन के काइनेमेटिकल इक्वेशन 3 हमने पढ़े हैं टिल इन 9th स्टैंडर्ड. कौन से है? v इक्वल टू u प्लस at, s इज इक्वल टू ut प्लस हाफ at स्क्वायर, एंड v square is equal to u square plus 2as. These are the 3 basic kinematical equation that we're going to use it in this equation. I'm trying to get the final equation for this projectile motion. So whichever the symbols that we have used earlier, we're going to repeat it here. ठीक है. So here you can see I'm showing one symbol for initial velocity which is u, which is the same like kinematical equation. So ये क्या है? Initial velocity. Whenever I'm talking about velocity, velocity is a vector quantity, so you have to show the direction. So this must be the direction of throw or direction of projectile with respect to theta. And as you have learned in scalars vectors, whenever there is a vector which can be resolved into its two components, right? So ये अगर velocity है, it can be resolved into 2 components. And as I'm having projectile motion, as I told you, projectile motion is a motion in a plane. So it involves x component, it involves y component. तो vector quantity है velocity vector of the inclination theta with the x-axis or to the horizon. So we can resolve the velocity vector into its 2 components. ठीक है. So which are those components? As you have learned in trigonometry mathematics, whenever the theta is adjacent, so adjacent definition is given in terms of cosine. So here I am showing one component of velocity vector which is u cos theta, and this is the horizontal component of velocity vector. Whereas ये वर्टिकल डायरेक्शन में भी कुछ पाथ या कुछ डिस्प्लेसमेंट कर रहा है ना अपना प्रोजेक्टाइल, ऊपर उठ रहा है ऐसे, तो वेलोसिटी अलोंग y एक्सिस वो भी एक कंपोनेंट बनेगा. तो वो कंपोनेंट होगा u y आई एम टेकिंग हियर व्हिच इज u sin थीटा, क्योंकि अपोजिट होगा ना वो. सो देयर आर 2 बेसिक थिंग्स फॉर इनिशियल वेलोसिटी व्हिच कैन रिजॉल्व इन टर्म्स ऑफ u cos थीटा and u sin थीटा. तो दिस इज कंपोनेंट अलोंग x and this is component along y. सी अभी मैं कुछ बेसिक चीजें एक टेबल में आपको बना के दूंगी which is we can say a trick to projectile motion. Once you have the knowledge of that table, means if you know how the displacement along x along y, what will be the velocity along x and y, if you know the idea of that things, you can get the knowledge of anything for the projectile motion. So I am just explaining the table which is not directly given in your book, but we can make in the table, and then we try to solve some things like time क्या है or what is the range, what are the height of the projectile, so and so things. So we try to form that table first, and which is for your knowledge. ठीक है. So first here I am making 2 things. Here I am making x-axis and y-axis. This is for your knowledge, right? Whenever you are writing projectile motion का derivation, there is no need to write this. By this table you can find out anything related to projectile motion. Okay? So x-axis पे क्या हो रहा है, y-axis पे क्या हो रहा है, that we going to discuss. देखो x एक्सिस पे अपना प्रोजेक्टाइल इज मूविंग विथ सम वेलोसिटी. नाउ आई टोल्ड यू कि वेलोसिटी इज ux व्हिच इज u cos थीटा. So can I write initial velocity of projectile along x-axis is ux, which is u cos theta. So I got the 1 point. This is velocity along x-axis, which is ux, which is u cos of theta. Try to remember the things. And on to y-axis means I got the 1 point, first point on y side also. Velocity along y-axis, which is uy, which is u sin theta. Clear है? ठीक है? That I have already explained. Now theta is angle of precession, that you know. Now you can imagine whenever the just forgot the things, forgot the y-axis, and just look on the x-axis. Whenever the projectile is traveling along x-axis, I am telling that this projectile motion is without resistance. I am neglecting the air resistance also. So no obstacle coming in the path of projectile along x direction. So along the x path, there is anyone to stop your projectile? No. So if there is nothing can change your velocity, so no obstacle within the path along x-axis, so velocity of projectile along x-axis will be constant because no resistance, no obstacle, no change in velocity. So your projectile will travel along x-axis with constant velocity. समझ रहे हो? So velocity along x is constant. But y पे क्या सीन है? देखो y axis पे you can clearly understand this is the somewhat trajectory of the projectile. तो ऐसे आराम से ऊपर उठ रहा है. But here the projectile got the maximum height, right? And whenever it achieve maximum height means उसके ऊपर वो नहीं जा रहा है. अगर ये उसका मार्क और मैक्सिमम डिस्प्लेसमेंट वाला पॉइंट है तो वेलोसिटी कंपोनेंट यहाँ पे जीरो हो रहा है y का, क्योंकि अगर और वेलोसिटी होती तो वो और ऊपर उठता. But you can clearly see projectile is stopped here. So velocity must be zero here. Then velocity again means is coming down with respect to acceleration due to gravity. So उसका speed और जैसे जैसे fall होगा वैसे वैसे increase होगा. So if I take some example of this, like यहाँ पे कुछ 3 मीटर पर सेकेंड से हमने थ्रो करा, वो ऊपर उठा 2 मीटर पर सेकेंड से, यहाँ पे 1 हुआ. When it reached to exactly to the highest point, it becomes 0. तो velocity component along maximum height कितना हुआ? 0. And is coming down, तो यहाँ पे फिर से 1 हुआ, जैसे जैसे नीचे आ रहा है 2 हुआ, यहाँ पे फिर से 3, and then it is 0 then. So this is how velocity component along y-axis is going to change. So can we say velocity along y component is changes? क्या लिख सकते हैं हम यहाँ पे second point? Velocity along y component means vy changes. कहाँ पे कांस्टेंट है? x पे कांस्टेंट है. तो जब मैं ये सेकेंड पॉइंट लिख रही हूँ तो मेरा एक उसमें हिडन पॉइंट क्या होगा? एक्सेलरेशन का. तो what is acceleration about x and acceleration about y? That we are going to discuss. देखो velocity along x component is constant and we know the acceleration का basic equation, rate of change of velocity. चेंज ऑफ वेलोसिटी, चेंज हो रहा है यहाँ पे वेलोसिटी? बिल्कुल नहीं. टी टाइम जब 0 था वो वेलोसिटी कुछ समझ लो 3 मीटर पर सेकेंड थी. यहाँ पे टी टाइम कुछ 5 सेकेंड हो रहा है, वो भी 3 मीटर. यहाँ पे जब तक वो फाइनल पोजीशन तक नहीं पहुंच रहा है along x, its velocity is going to be constant. So rate of change means final minus initial जो आ रहा है which is 0. तो acceleration along x component कितना होगा? Acceleration along x component कितना होगा? 0. समझ गए ये चीज? So I'm showing here acceleration by symbol ax which is 0. तो जहाँ पे acceleration component की बात हो रही है तो which is 0. But when we talk about the y component, something is changing. Who is changing? Velocity is changing. As you can clearly see, 3 से 2 जा रहा है, 1 ऊपर उठा, सबसे maximum height तक पहुंचा, वहाँ पे speed will be 0. Then it is increasing whenever it is coming down. ये क्यों हो रहा है? Because there is someone who is pulling your object in downward direction only. which is a gravitational force, right? And as you know, by the gravitation हमने पढ़ा है, तो जैसे ही किसी ऑब्जेक्ट को आप ऊपर फेंक रहे हो तो इज कमिंग डाउन विद रिस्पेक्ट टू एक्सेलरेशन ड्यू टू ग्रेविटी. तो देयर इज ओनली वन acceleration which will work along the y component, which is ay, and which is acceleration due to gravity. हमेशा वो नेगेटिव डायरेक्शन मींस नीचे के डायरेक्शन में लग रहा है, तो वी कैन शो इट बाय नेगेटिव साइन. सो y कंपोनेंट पे क्या हो रहा है, वेलोसिटी चेंजिंग, सो एक्सेलरेशन आल्सो चेंजेस. सो यहाँ पे क्या होगा, ये एक्सेलरेशन क्या होगा, एक्सेलरेशन ड्यू टू ग्रेविटी. तभी तो हम प्रोजेक्टाइल मोशन को बोल रहे हैं ना, is a projectile motion which is a planar motion, means जिसमें x and y component involve हो रहे हैं, and this is the motion under the action of gravity. So gravitational force will work there. So acceleration due to gravity we have to consider, which will work along negative direction of y axis. So acceleration along y is जहां जहां आपको ay दिखे means acceleration of y component, which is acceleration due to gravity, and you have to show it by negative sign because is only along negative direction of y axis. So and this is acceleration along x axis which is 0. तो उसने maximum displacement कहाँ करा होगा, जब वो velocity component जैसे 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 ऊपर जा रहा है यहाँ तक पहुंचा, तो ये this is the maximum height achieved by the projectile, right? जहाँ पे क्या हो रहा है, velocity component 0 हो रहा है. तो we can just sum up this idea as projectile moving in upward direction, height becomes maximum when Vy is equal to 0. Means whenever height h becomes maximum, जब velocity component 0 होगा. अगर उसके ऊपर और velocity होती तो और वो ऊपर उठता ना, समझ गया? तो this must be the height. So this is what exact we can say the hint point for projectile motion. If you know this table, you can easily find out any equation for projectile motion. So we try to find out equation of projectile motion. We need to check with what is the curve, or is curve कौन सा curve है, whether is hyperbola or is parabola or is ellipse. Straight line तो नहीं दिख रही, समझ गए? So we try to find out the equation. We can relate the equation to the equations of the shapes. Okay, so let's start. So we should start with the basic. As you know, velocity का basic definition क्या होता है? Velocity का basic definition is distance upon time. तो x axis पे वो कुछ velocity लेके चल रहा है, y axis पे कुछ velocity लेके चल रहा है, तो we just use equation of velocity along x axis. See, अभी प्लेन बोल रहे तो x and y दोनों को कंसिडर करते हुए चलना होगा. तो x पे क्या हो रहा है, y पे क्या हो रहा है, दोनों को मर्ज करो, you will get the knowledge of projectile motion. x y का है ना, is a planar motion. Is that clear? So along x axis क्या हो रहा है, x axis पे velocity का इक्वेशन लिखते हैं. Velocity along x axis vx is equal to distance upon time. Is that clear? ये distance कितना है, x upon t. समझ में आ रही बात? So if I try to write this equation again, t बराबर x upon vx equals to, but vx यहाँ पे मैंने लिखा है, instead of v I have used your ux. u क्या है, initial velocity, so I would write this ux. तो ux, what is the equation of ux? means x के along velocity क्या है, u cos theta. So जो हमने टेबल बनाया है उसी का यूज करेंगे और we will find out the derivation. So ये क्या होगा, x upon u cos of theta. So this must be the equation number 1. We got the idea for the time period along x component, right? Then along y component, y axis, ठीक है. y axis पे हमें एक काइनेमेटिकल इक्वेशन यूज करना है. 3 काइनेमेटिकल इक्वेशंस हमने पढ़े, उसमें से जो सेकेंड काइनेमेटिकल इक्वेशन है कौन सा है, s is equal to ut plus half at square. This equation I'm going to use. तो वो इक्वेशन हम कैसे यूज करेंगे, s माने डिस्प्लेसमेंट, यहाँ पे मैंने क्या निकाला था, वेलोसिटी, माने इन टर्म्स ऑफ डिस्टेंस, राइट? तो यहाँ पे मैं क्या निकाल रही हूँ, डिस्टेंस ही निकाल रही हूँ, बट कहाँ पे, y कंपोनेंट पे। तो ये डिस्प्लेसमेंट कहाँ कर रहे हैं हम, y कंपोनेंट पे, तो s बना y। समझ के अंडरस्टैंडिंग से लिखो, इट इज वेरी इजी। s इज इक्वल टू y, ut, u क्या है, इनिशियल स्पीड, तो ये u क्या होगा, y का स्पीड होगा, विच इज uy एंड विच इज u sin थीटा, राइट। a क्या है, a क्या होगा यहाँ पे, ay, जो y कंपोनेंट का एक्सीलरेशन होगा ay एंड विच इज minus g. Just we would substitute the values in this equation and we will get the knowledge of displacement along y component. So let's see, s यहाँ पे क्या हो रहा है, y equals to u क्या हो रहा है, u sin theta of t as it is plus half a क्या है, ay t square। तो ये थोड़ा और रीअरेंज करो, y बराबर u sin थीटा इंटू टी माइनस हाफ, क्योंकि ए वाई क्या है, माइनस जी, तो माइनस साइन में यहाँ पे लिख रही हूँ माइनस हाफ जी टी स्क्वायर। ठीक है, ये y का डिस्प्लेसमेंट बना, ये x का डिस्प्लेसमेंट बना, मीन्स x इज u cos थीटा बाय t, राइट। अभी क्या करना है हमें, वी हैव टू सब्स्टिट्यूट टाइम इन टर्म्स ऑफ x displacement into this equation. So anyway I'm trying to merging these two equations so that we can get the knowledge of x y, means प्लेन का कुछ जो मोशन हो रहा है वो मर्ज हो जाए, तो प्लेन की मोशन नथिंग बट प्रोजेक्टाइल मोशन, समझ गए। सो जस्ट आई एम सब्स्टिट्यूटिंग t का वैल्यू फ्रॉम इक्वेशन 1 इनटू दिस इक्वेशन, तो ये इक्वेशन कुछ ऐसे बनेगा, y इक्वल्स टू u साइन थीटा इंटू t क्या है, t देखो यहाँ पे x अपॉन u cos थीटा, x अपॉन u cos थीटा माइनस हाफ t अगेन सब्स्टिट्यूट x अपॉन u cos थीटा का स्क्वायर। ठीक है, सो ये इक्वेशन कुछ ऐसे होगा, y इक्वल टू u साइन थीटा अपॉन cos थीटा, tan थीटा होता है, u गेट्स कैंसिल, रीअरेंज करो, x tan ऑफ थीटा माइनस हाफ ये x स्क्वायर होगा, तो g x स्क्वायर अपॉन नीचे होगा u स्क्वायर cos स्क्वायर थीटा। So here I got equation of projectile motion. You can clearly understand theta, देखो किस प्रोजेक्शन किस एंगल से उसको फेंक रहे हो, that decides the projectile path. x कंपोनेंट भी उतना ही इंपॉर्टेंट है, y कंपोनेंट भी उतना ही इंपॉर्टेंट है, एनीवे acceleration due to gravity, क्योंकि this is motion under the action of gravity, so gravitational constant is also involved in the equation of projectile motion. So whenever we can use the projectile motion, so we have to use this basic equation of projectile motion, which is y बराबर x tan theta minus half g x square upon u square cos theta. We will just substitute the constant and will relate the equation to the shapes का equation and we'll check whether which shape it is. ठीक है, so I am just substituting tan theta as a or alpha. In some of the books you will see a as a constant, in some of the books you will see alpha as a constant, but we will go by the textbook, which is tan theta equals to alpha, and here half g u square cos square theta, this whole constant I am taking, so half g square upon u square cos square theta, the whole thing I am substituting as beta, so your equation becomes y equals to alpha x minus beta x square. And you might be aware of, while you are doing mathematics, you might be seen this equation, वहां पे कुछ ऐसे होगा ax minus bx का स्क्वायर या alpha x minus beta x का स्क्वायर, दिस इज इक्वेशन ऑफ पैराबोला। ये क्या है, दिस इज इक्वेशन ऑफ पैराबोला। So can we say projectile path या trajectory of projectile motion is parabolic? तो क्या नाम है उसको, क्या बोला जाता है, trajectory of projectile motion is parabolic. ठीक है, I hope you understand this. यहाँ पे हमने क्या दिखा है, u cos theta is a component of initial velocity along x component. This is u sin theta is component of y, initial velocity along y component. तो जहां जहां वो आगे चलेगा ये u cos थीटा, u cos थीटा, u cos थीटा, u cos थीटा, यहाँ तक वो कांस्टेंट बनेगा. यही हमने लिखा है वेलोसिटी अलोंग x कंपोनेंट इज कांस्टेंट. वेयर जैसे वो ऊपर उठ रहा है तो वहां पे क्या हो रहा है, थीटा देखो u sin थीटा, u sin theta, u sin theta, u sin theta, this is going to be change क्योंकि theta change हो रहा है. So velocity along y component changes, it initially increases, reaches to maximum height, becomes zero, then it start decreasing. समझ गए? So this is what projectile motion. So I think you have understood this equation of projectile motion. We will discuss some derivation related to range of projectile, height of projectile, and टाइम ऑफ फ्लाइट. फ्लाइट मीन्स प्रोजेक्टाइल ट्रैजेक्टरी को कवर करने के लिए कितना टाइम लगा, वी विल डिस्कस इन नेक्स्ट लेक्चर. टिल देन बाय.